Welcome students. Today we will discuss about introduction to cryptography. So cryptography is an art of achieving security by encoding messages to make them non-readable. So before going into deep, we will discuss some of the basic terminologies of cryptography. So first is that the plain text. Plain text is nothing but an original message, and second is ciphertext. Ciphertext is basically the non-readable message or a coded message. So as you can see here that this is my algorithm that's called as the encryption algorithm. I'm denoting it with capital E, and it is associated with some key, right? So in this particular case, this plain text as the input acts as input to this particular encryption algorithm, and this ciphertext acts as output. So this encryption algorithm is responsible for converting my plain text into some ciphertext with the help of this particular key K, right? This particular key K. So you can see here we have a term as a cipher. Cipher is nothing but this is an encryption algorithm that is used for transforming my plain text into the corresponding ciphertext, right? And I told you that there is some key K that is used by this particular encryption algorithm. That is, this encryption algorithm makes use of a plain text as an argument, and the second is key, right? These are the two arguments of this particular algorithm, that is capital E, right? And this entire process is called as the encryption. This process is called as encryption, and encryption is nothing but to convert my plain text into the corresponding ciphertext so that it remains secure throughout the communication channel. That is called as encryption, right? So we have to make always we will try to enhance this particular encryption algorithm to make our message more and more secure, right, throughout the communication channel, right, by providing strong encryption. So second is called as the decryption. Decryption is basically the reverse of encryption, right? If we are writing this particular decryption, so decryption is basically the reverse of encryption. It means that it includes the input as the ciphertext, and output as my plain text. And if I write the if I write this particular D with the, it also includes some keys, the same key that we have used in our encryption. If this is a symmetric process, we will later talk about the symmetric or asymmetric, but till now you only understand this thing. We are using this particular key, and the same key is used in the process of decryption. And for decrypting this particular, we are making use of the ciphertext and the corresponding key as K, right? So the process or to recover a plain text from the ciphertext is called as decryption. And next, there are the three terms in this particular slide. The one is called as the cryptography, second is cryptanalysis, and third is cryptology. So this is my first, right? This first is basically, this is called as cryptography. This is called as cryptography, right? That's the process of encrypting, right, a plain text into a ciphertext, or process of converting a plain text into a ciphertext is called as encryption, and the reverse of this is called as cryptanalysis. This is called as cryptanalysis, or code breaking, right? That is a deciphering, right, or decryption. And so this is my second thing. And if I combine this first and second, that the cryptography and cryptanalysis, then the broad term is the field of both the cryptography and cryptanalysis is called as cryptology. It's called as cryptology. So I told you that encryption is also a two kind of encryption. One is called as symmetric, right? Symmetric, and second is asymmetric. So we will first of all try to discuss about symmetric encryption, right? Okay, or symmetric cipher model. So symmetric encryption, what is the symmetric encryption, right? So Now we are focusing on our next topic in cryptography, that's the basic topic that's called as a symmetric encryption, right? Symmetric. So symmetric makes use of a common key. We call it the single key or a private key. That means the sender as well as the recipient. Okay. Sender and recipient will share the same key. Will share the same key. K. Right. Okay. So for example, what we are trying to say, we have this particular plain text. Right. I'm encrypting this particular plain text with the help of some encryption algorithm. So I will get here some ciphertext C. Right. This is my ciphertext C, right? Now this encryption is done with the help of some key K, right? Now this is my sender, for example, and I will send this particular ciphertext over the communication channel, right, towards the another end of decryption, right? Now this ciphertext acts as my input in my decryption, and this is my, for example, recipient or recipient. Right, so it makes use of the same key in case of symmetric, right? It makes use of the same. This is K1, this is also K1, right? And by making use of this particular key and the algorithm for decryption, right, it's nothing but the reverse of my encryption, right? There is nothing but the reverse of my encryption. We achieve that particular, right, or retrieve that corresponding plain text, and this is called as symmetric encryption, right? This is the entire process is symmetric encryption. Right. So the same thing is shown in this particular slide. You can now see much more clear way that this is my symmetric cipher model and this is my plain text. This is my encryption algorithm. For example, we are using here a symmetric encryption algorithm, the most popular symmetric encryption algorithm that's called as DES, right? And it uses a key of 56 bits, right? That we will study in coming video lectures. So this DES basically stands for data encryption standard. This DES stands for data encryption standard, right? So this is my ciphertext. This ciphertext acts as the input for recipient. Recipient share the same key. This is key here, right? And it makes use of decryption algorithm, that's the reverse of encryption, and deciphers into the plain text. Act as the output here. All right. So now what are the requirements? Again, this is written in some mathematical way that we have to understand also because these are used widely throughout this particular topic. So this is nothing but the same thing, right? This there have y acts as the x acts as input, right? This is my plain text. I am writing as plain text PD, and this is my ciphertext CT, right? This EK stands for my encryption algorithm. This stands for my encryption algorithm having some key K, right? And it says this plain text acts as an argument and it converts that particular plain text into y is nothing but a ciphertext. The reverse is this one, right? Okay, you can see here that D of K is basically my decryption algorithm with some key K and it converts into the corresponding plain text. Next is cryptography. So in this particular case, we are characterizing cryptography system by three terms. One is called as the type of encryption methods. Second is number of keys used. Third is way in plain text is processed. Okay, so cryptography is basically the art of achieving security by encoding messages to make them non-readable. Now, in this particular slide, we are characterizing a cryptographic system. There are the three things by which we can characterize the cryptographic system. One is type of encryption method. Second is number of keys used. Third is way in which my plaintext is processed. So this is the most important thing, right, that we are discussing now. This is quite important, right? Okay, this is used in much elaborative way now, right? Okay, we have first of all type of encryption methods. So there are three types of encryption methods. One is substitution, second is transposition, and third is product ciphers, right? Second is the number of keys used. So as I told you, we have a symmetric encryption as well as asymmetric encryption. In case of symmetric encryption, we have a single key system, and in case of asymmetric, we have two keys. And the way in which the plain text is processed, there are the two ways. One is block, in terms of block ciphers, and in terms of stream cipher. In terms of block ciphers, we take a block of bytes, okay, or block of characters, and encrypt the entire block, right? Encrypt the entire block, right, into the corresponding ciphertext. For example, if this block is of 8 bytes, if this block is of 8 bytes, then the entire 8 byte will get encrypted into the corresponding ciphertext of the same 8 byte. The example is DES, data encryption standards, or Fistel ciphers. They make use of block ciphers, okay. Stream ciphers are basically, they are used to convert a plain text to a ciphertext bit by bit or a character by character. They are used to convert a they are used to convert a plain text into a ciphertext character by character, right, or bit by bit. That's the difference between a block cipher and a stream cipher, right? For example, a Caesar cipher, right? Caesar cipher that makes use of this is a kind of a stream cipher, right, or a Playfair cipher. So this is the things that we have to always consider, that to characterize a corresponding cryptographic system. One is the type of encryption method. One is called as the substitution. Substitution basically replaces one character with another. Transposition method basically uses permutation, right? Uses permutation, right? And a reordering, some kind of reordering. And product cipher is basically a sequence of ciphers that we are apply one by one. Okay. So in case of cryptanalysis is basically a technique of decoding messages from a non-readable format back to the readable format. We have some general approaches. One is called as the cryptanalytic attack, and second is brute force attack. So in case of cryptanalytic attacks, we have a knowledge about ciphertext only, known plain text, chosen plain text, chosen ciphertext, and chosen text. Okay. And in case of brute force search, we try to make the possible combinations, right? Okay, for cryptanalysis. That, for example, if the key size is 32 bits, then the number of alternative key combinations are 2 raised to the power 32. If the key size is 56 as used by our DES, right? Our data encryption standard makes use of a key size of 56 bit. So the number of combinations are 2 raised to the power 56 and so on, right? Thank you.